Today I'm going to show you how to install and run the GNU Scientific Library. The GNU Scientific Library will allow you to run a lot of statistical and mathematical analysis in pure C, just from your terminal. So stuff like regular statistics, correlation, linear regression, nonlinear regression, mathematical analysis like filtering, Monte Carlo integration, ordinary differential equations, vector and matrix analysis. There's a lot of things you can do. It can be really useful if you want to do all your stuff in pure C. So to be able to run this library, of course you have to have your C compiler installed in your computer. As usual, we are in Linux, so we have the GCC compiler installed, and we're going to install the GNU Scientific Library and test it and do some basic analysis to see if it works okay. So the first thing you need is to download the folders, the compressed folders. Just going to click here. Mine is going directly to my downloads folder. I already have it downloaded, so I'm not going to do anything. There's another option where you can go to the mirror or FTP sites, and you can download the files from there, and you can validate your downloads, the signature of your files, if you get it from the mirrors or any mirror. So the files are also here. You can download it here. So we're going to be downloading GSL 2.7.1, and you can get the key here. Just save it in the same folder, and you can run using these commands to verify the signature. We're not going to do that. We're just going to download it directly from here. So we download it directly from here. What we need to do now is go to our downloads folder. Mine is because I'm saving stuff in my downloads folder or whatever you downloaded. Just go to your compressed file, click extract here. Mine is already extracted, so this is where the extracted files are. So now we're going to need to compile it. Let's look at the terminal here. Okay, so I'm going to go into my downloads folder, and I'm going to open the GSL folder. Okay, it's just clear here, so we go to the beginning. Let's see what's in here. So if you can just cat here, or you can go into Vim or whatever text editor you use here. So let's look for the file. Let's look at the file install, and here you're gonna have the instructions for installation. Basically, if you don't want to read through all of this, what you need to do, you should read through all of this, of course, but if you just want to install it, just go here, configure, and make and make install. You just run those three commands. I'm going to run all of them at once. Of course, you need to be logged as root. If you're not logged as root, you're going to have some troubles at the end of the installation, and not everything is going to be installed. You can either run configure and then make install, or using this and here, run all at once. I already run it. Mine is already installed. So it's just going to go. It's just going to go through all the procedure, and then just do the verifications. Okay, this errors here, it's because obviously because it's already installed. and because I'm not logged as root. But if you're logged as root, you're not going to see those errors, and the full installation would take, depends on your computer. This computer, it's not very powerful, so it takes about 5 to 10 minutes for the installation. So it is already installed. Now we're going to need to test it. So how are we going to test if the installation worked okay? So let's go back to the GNU Scientific Library website, and let's do the first example that they show here. The first example here is for computing a Bessel function J0 of x for x equal 5. We're supposed to see this output here. So what you want to do is you copy this here. You can save it at using some text editor. Mine, I'm just using pure gedit here. I'm going to save this. I already have it saved because I tested before. So I'm going to save it at my C programs folder and call it Bessel.c. Okay, so let's replace here because it doesn't matter. So here is our C code. You can't just, let me clear this here. You can't just run, for example, gcc Bessel.c Bessel unless the installation was done at the adequate path, which we did not worry about this right now. We just installed at the easiest place. This type of code here will not run. So what we need to do, let's try to follow the instructions here at the GNU Scientific Library website and see what happens. So first we have to compile and then link the file. Let's look at the code first of all before running. We have here including standard input output file here, the standard file, and this is a file for the Bessel function from the GNU Scientific Library. It main void double declared x, declare y as the Bessel function, and then here we print the value for x equals 5. So let's try to see how we can run this. First of all, the first command that we need is for compiling. Just going to copy this here and paste here. Let's come back to my C folder. And then let's try to compile it here. Let's just clear here. Of course, we need to change the file here for our example. So this here gives us a path for the files needed to compile this file using the GNU Scientific Library. So nothing happens at first. So let's take a look what happened here. So here we have our Bessel function, and compile this Bessel function generated this Bessel.o. This here is not generated at this step, but we can't do anything with this Bessel.o file. We need now to link it. So if you come here, the command for linking using this lgslc blast library in the lgsl library, let's just copy here. I'm gonna link it here. Paste. Let's change the name to the file that was produced when we compiled, Bessel.o. So now it didn't generate this Bessel file yet because we need to ask for the output, the Bessel file. Remember, it is here because I generated when I was testing before starting the video. So if you start, let me just show you this here real quickly. I'm gonna remove the files Bessel.o, and I'm gonna remove the Bessel because those were here before I started to record. So when you run the compiler, let's see here, you have the Bessel.c file and the Bessel that was compiled and the Bessel.o file, but not the Bessel file, which is the one you want to run for you to do your calculations. So let's clear this here again. Now what we need to do is we use the linking command asking for the output file Bessel here. So this is the file that actually we need to do the compilation. So let's see here at the folder again. Now the Bessel file is here. Let's try to run this Bessel file. And now we have the value of the Bessel function at j equals 5 as expected. But there's an issue here. Sometimes there's problems here with the path, and if you have problems with the path, sometimes the path will not be found, the file will not be found. You have to provide this command here to set the search path. So if you have problems at that step, what you need to do is run this command here. Run this command here. Notice that I ran this before, that's why it's not asking me to do it right now. And then you should be able to run your Bessel function without problems. Okay, so let's put all those commands together so we can use it to do any other analysis that we want, statistical analysis that we want. So for compiling, we need this here. This is for compilation. This is for linking. Remember, we have to define the output here. So let's call your file or my file. Here again is your file. Your file. And for setting the paths here and running the file, executing the file, you're going to use this here. Okay, so here is going to be your file. So for the Bessel function, so okay, the first one here was actually the second, and this is the correct first one. So let's just put this one here. Let's call it here your file as well. And here, let's put it Bessel. So we can run our full test now, okay? So let's copy all this and paste it here. Still missing the file name here. Remember, you can set this as a bash script. It's pretty straightforward to do. Okay, so now let's clear. Let's try again. Okay, so now we can run the full file. Now, let's do an example for simple statistical analysis. So let's check this code here, which does simple statistical analysis, mean, standard deviation, and variance. There's an example code here, sample code here. We're going to copy this whole thing here. And we're going to save it as, let's call it statistics.c. Okay, so what we have here is functions for simple statistics from GNU Scientific Library. We have 5 data points, and we're going to ask for the median, upper quartile, lower quartile. And here are the functions for the lower quartile, upper quartile, and the median. In other videos, I'm going to show other functionalities of this library, but this here is just an example. So to run this here, the code is pretty straightforward, calculates the quartiles and the median, and prints the values to the stream. So let's modify our path, our code here to run the code called statistics. So let's change this here for statistics.c, which is the file we just saved. The output from the compilation will be statistics.o, and the link it will provide an executable file called statistics. And we're going to run it after fixing the path issue. Remember, if you do it this the first time in your section, you don't need to do it all the time. But we're going to do it all the time. There's ways of linking this straight on your paths on your computer, but we're not going to mess with that at this point. So let's clear this here, and let's run the whole code. Okay, so the output is, here's the original data set, the sorted data set, the median, the quartile, the upper quartile, and the lower quartile. There's a lot of interesting functions. I'm going to try to do them in other videos, but for now, this is the procedure for installing and testing the GNU Scientific Library for statistical analysis and mathematical analysis in pure C.